All right, let's jump right in. We hear it all the time, right? AI is getting smarter, more like us. But what if that's completely backwards? What if the reality is something weirder? Today, we're diving into the massive gap that's opening up between how AI works and how our own brains work.
And look, it's an easy assumption to make. You see an AI writing a poem or making a piece of art. You see it holding a conversation, and you just think, wow, it's becoming human. It feels like it's on the same path we are.
But here's the twist. The science is pointing in the exact opposite direction. It's a huge paradox. The smarter AI gets, the less it thinks like a human. As we push these models for superhuman performance, they're not copying our brains, they're evolving their own strategies. Strategies that are, well, for lack of a better word, totally alien. Okay, so how are we going to break this down? We're basically going to climb a ladder, starting from the ground up. We'll kick things off with the physical stuff, the hardware. Then we'll move up to how they learn, then how they think, and finally, we'll get to the really big, spooky question. What does it all mean? Let's get into it.
All right, first stop, hardware. This is all about the deep physical gap between our biological wetware and the silicon chips AI runs on. You know, we throw around this term artificial neuron, but honestly, it's a bit of a stretch. Think of an AI's node as a super simple calculator. A number comes in, gets multiplied by another number, and a single number goes out. That's it. A real biological neuron? Whoa, that thing is a complex computer all by itself. It's doing intense calculations in its little branches long before it even fires a signal. It's using electricity, chemicals. I mean, they're not even playing the same sport.
And all that incredible biological complexity, it leads to this. This is just mind-blowing. Your brain, right now, listening to me, processing all this information, it's running on about 20 watts of power. 20. That's a dim light bulb. It's just wildly efficient.
And this is where we see what some researchers call the thermodynamic abyss. Look at this. Our brain is sipping power at 20 watts. Just one of the GPUs these models run on, 700 watts. A whole cluster of them for training, we're talking megawatts. Literally the power consumption of a small town. This isn't just a small difference in efficiency. This is a chasm. It tells us that AI isn't just a power-hungry version of us. It's doing something fundamentally, physically different.
So that huge hardware difference naturally leads us to the next rung on the ladder, learning. How do these two systems actually get smart? And here, the gap gets even wider.
Okay, so the main way AI learns is through this algorithm called backpropagation. It's mathematically beautiful for sure, but from a biological standpoint, it's got this one giant problem, something called the weight transport problem. Basically, for an artificial neuron to adjust and learn, it needs to get a perfect error report sent backward from every neuron in front of it. There's just no wire for that in the brain. We have no known biological way to do that. It's why a lot of scientists just say it's biologically implausible. It just couldn't work in our heads.
And this isn't just a theory, we can actually test it. When you put a bio-inspired learning method up against AI's backpropagation, you see this really interesting split. If you only have a little bit of data to learn from, the biological method wins, hands down, by like 20%. It figures things out in just a handful of attempts, where backprop might need hundreds. It's clear what's going on. Our brains are built for survival, for learning fast from just one or two experiences. AI's method, it really only shines when you have endless data and a ton of computing power to throw at it.
And that leads to another kind of crazy difference in learning. It's called catastrophic forgetting. Think about it this way. A person learns about cats, then they learn about dogs, and now they know about both. Simple. But for an AI, you can train it to be the world's greatest cat expert. Perfect. Then you take that exact same AI and teach it about dogs. What happens? Poof, its knowledge of cats can be completely gone. Erased. It literally overwrites its own memory. We accumulate knowledge. AI often just replaces it.
All right, climbing up again, let's move from how they learn to how they think. We're talking about the high-level architecture here, the difference between a mind that lives in a body and one that just exists in the abstract.
So, to really get this next part, we need a quick idea from cognitive science, dual process theory. The short version is that our brains have two gears. System 1 is our gut instinct. It's fast, automatic, it's all about pattern matching. System 2 is our slow, deliberate, logical reasoning. It's when we stop and actually think about something. We flip between these two all day long.
Okay, so here's the kicker. A modern large language model, it's basically a gigantic, superpowered System 1. It is a pattern matching machine on a scale we can barely imagine. It's amazing at that fast, intuitive stuff. But it doesn't really have a system too. It doesn't have that second gear for slow, deliberate thought. It can imitate reasoning if we tell it to, but it's not its native state. It's all instinct all the time.
And that lack of a built-in reasoning system points to something even deeper, which this quote nails. These models are essentially brains in a jar.
So what does disembodied really mean? It means our intelligence is rooted in the physical world. You know what heavy means because you've lifted something heavy. You know balance because you've almost fallen over. Our concepts are grounded in physical experience. In AI, it learns about the world by reading text about it. It knows all the words associated with thirst, but it has never felt thirsty. It's describing a world it has never touched, tasted, or felt.
And that leads us right to the top of the ladder, to the biggest, most philosophical question of all, the ghost in the machine. We're talking about meaning. What is the real difference between just predicting the next word in a sentence and actually understanding it?
This is a classic idea in philosophy called the symbol grounding problem. Think of it like this. An AI learns that the word apple is related to red, fruit, and tree. But if it's never actually seen or tasted an apple, how does it know what it is? It's like being trapped inside a dictionary. You can look up a word, and the definition just points you to other words. You're forever stuck in a loop of symbols, never connecting them to the real thing. And you can really see this lack of grounding in the way they make mistakes. We say an AI hallucinates. What's really happening? It's a statistical error. It's just spitting out a sequence of words that is probable, but factually wrong. It's a parrot. But when a human gets something wrong, we call it confabulation. Our brain isn't just spitting out random facts, it's trying to fill in gaps in our memory to build a coherent story. AI's errors are statistical. Our errors are about making sense of our own narrative.
This even applies to creativity. There's this great framework that breaks creativity down into 3 types. AI is amazing at the first 2. There's combinational, mixing existing ideas together in new ways. And there's exploratory, pushing the limits of a known style, like writing another sonnet. But the third kind is transformational. This is where you don't just play the game, you invent a whole new game. You invent jazz or cubism. That kind of rule-breaking, for now, that still seems to be a purely human thing.
So after climbing that whole ladder, what's the big picture? It kind of forces us to reframe everything. We aren't looking at one intelligence trying to catch up to another. We're looking at 2 completely different kinds of minds.
Here's the bottom line. AI isn't a cheap imitation of a human brain. It's not a lesser version of us that's slowly getting better. It's something new. It is an alien intelligence, one that's optimized for pure scale and accuracy. Our minds, on the other hand, are optimized for survival and finding meaning. These aren't 2 things competing for the same job. They're complementary.
And so that leaves us with one last big thought. Maybe we've been asking the wrong question all along. Instead of worrying about if or when AI will think like us, what if the real exciting question is, what incredible things can we discover by thinking with it?